welcome to my talk. I'm recording this video from Spain, where I'm based. I hope you'll enjoy it. I hope you're having a nice day. And I would have still very much like to interact with you. So if you have any questions, comments, ideas, or if you just want to say hi, feel free to reach out to me after the talk. I'll share my contact details right at the end. So let's go. Move fast without breaking things. Probably you heard the opposite of this phrase from here, where it started like, I think maybe 10 or 15 years ago, where it became Facebook's one of the mottos of Facebook. And this is funny actually, because I remember I first seen this phrase in my first office, one of my first offices in Istanbul, Turkey, where I was working in one of the largest banks in Turkey as a software developer, and this phrase was written on top of the wall right next to my desk. And it was a bit confusing because this bank is run with strong hierarchy, stability, and quality is everything. Like, perception of quality is everything, both individually and both of the systems we build. And to be honest, we deal with money, and it's a banking system, so there's not much room for error or to break things. So it was a bit confusing for me. But for the case of Facebook, it actually makes a lot of sense, and it's great. It's a great vision, as what great leaders should do. They say great visions, and I think Move Fast and Break Things states that pace is the priority, even on the cost of breaking things. They wanted their employees to feel safe, to not fear about breaking things, because they want to innovate. Facebook created new user habits first. They invented new user habits first and wanted to go further. They wanted to invent newer things. They want to invent better, faster things of interacting in web. So that's why they went with it. Up until it became this. So not too after, or like maybe let's say recently, a few years ago, Facebook adopted Move Fast with Stable Infra. So they're both valid approaches, but different times call for different measures. So why would any company would prefer this Move Fast with still having a stable infrastructure, stable performance, over just pure pace? So of course, there's an obvious reason where now user base expects a certain level of threshold of performance. You want to comply with the standard of quality, but there are a few other things, maybe like not too obvious things, that I want to mention here to consider high or like good performance. First of those is experimentation, where I've seen this in my workplaces where we've shipped an experiment, we shipped a new feature, an idea as an experiment to get feedback to see how it's going to perform. But the thing is, what we missed was the specific feature idea was performing, like the performance to quality was a little worse than the actual product, because we just wanted to be fast. But then the experiment result were the users didn't like this idea. But actually, soon after, we found out that it's not that users didn't like the idea. It's just that that feature was slow. It wasn't performing well. It wasn't really in high quality. That users didn't value. Users didn't want to use it. They dropped out. So during experimentation, it's really crucial that you meet your current quality standards, so that users don't, even if they don't notice this consciously, they wouldn't just want to drop out. They wouldn't want to be annoyed with your product. And the next one is morale. So when you ship things that every once in a while breaks, and like when you break things, you have to go fix them. And when you ship things that breaks often, then you have to go fix them quite often and spend a lot of time on it. So every once in a while, this is fine. But if it happens quite frequently over a long course of time, in the mid and long term, this would actually bring down the morale of your teams a lot. So this is also something you want to consider. And the last thing I want to mention is, I think this is something I really want to emphasize, which is, like, more than often, spending 10% extra time and effort will probably prevent 90% of the issues you'll face later otherwise. I think this is almost always true in my personal experience, and I think with the content that I'm just going to be telling you about, I'm going to be supporting this idea. And maybe now it's time to talk about, like, why am I talking about this? Like, why not for something else, or why not someone else is talking about these but me? I think it's a good time to explain myself, like my past, my experience. So I've been working in tech for 10 years. For the past 10 years as a software engineer, I call myself a product management engineer. I love solving users' problems, and I've been grown from a junior engineer to a technical lead. I've led teams. I've mostly worked in ThoughtWorks in the past, where I've started in Turkey, and I've then worked in Germany, India, and then Spain. Finally, where I settled. I've been living here for the past 5 years, and I worked in various different domains: banking, e-commerce, pricing, betting, and then in New Relic, I moved to New Relic to the observability domain. I've had an amazing few years, and then since the beginning of this year, I'm working on Shopify. So I worked a lot with distributed systems. I had the luck to build that muscle, and I'm really interested in complex systems and how people. I'm fascinated by the characteristic of the complex systems, the complexity, and especially how people struggle or can manage with that, deal with that. So I've led teams that own and build, or been part of teams that own and build really high scale systems that demand really high quality. Like for example, New Relic processes and serves telemetry data. They own perhaps the biggest Kafka cluster in the world and requires excellent operational quality, because actually that's the product where other companies need when things are going tough or during critical days like Black Friday, Cyber Monday, which is happening now where I'm recording this. Or now I'm building in Shopify. I'm part of the Shop app. My team is responsible of helping our users to track their packages, track their orders. And at days, we process more than 20 millions of status updates, track order updates to be able to let our users know the latest status about their orders. And while managing this complexity, my teams have always been under pressure of moving fast. So and I want to share my experience of how did we balance those two things. So it all starts with planning, right? If you want to go really fast, but also keep a high level of quality, you need to plan accordingly. And first thing I've been really happy about when we achieved this was setting our priorities straight. So there'll come a day for a lot of people or more than one person in the team where we'll need to make a decision between time, performance, scope, quality, security, things like this. We need to choose one or the others. There's this trade-off coming. There'll come a day that you need to make a choice within this trade-off. And I think a team should be doing the most important thing at any given time. So this is my motto. And in order to be able to do that, consider one Wednesday morning, you show up to work, there's two things you can do, or someone in your team. Like you can just do something to make your application more secure, or you can do this other thing that's a performance optimization. So which one you would do? Instead of just relying on making the right choice every time for individuals, I think we should just like set our priorities straight and known and broadcast them clearly, so that this choice is straightforward, so that this choice is almost known. I think setting your priorities clear in the beginning will, as I wrote right here, will make your team work on the most important thing at any given time. And how do we achieve this? So there are like workshops like trade-off sliders and such, where you don't have to go in a full-on formal practice. It could be just a 20-minute talk. I think it just makes sure to reach this state. And once it's done, of course, we have a problem, we have an idea, we're going to design, right? In big tech, mostly we have this already running complex architecture, and we're going to add to this. We're going to add some logic, possibly some infrastructure. And how do we go about this when we still want to move really fast? Because there are like many things can impact this architectural decisions, right? Like if we believe this system is going to grow in a certain way, if we need to scale in a certain way, if we believe we may add some logic in a certain way, they all factors in impacts this decision. But there's this one concept I want to talk to you about that's actually coined by my former employer ThoughtWorks. It's called evolutionary architecture. So when you put this adjective evolutionary in front of architecture, I think that implies few things. Like one of them is it makes architecture a living entity. Now we accept architecture is a living entity and it changes, right? It evolves. And now we have a choice then, right after. We can just let it drift away, let it evolve naturally, or we can make it consciously, right? We can change it consciously instead of letting it drift in time. So how does this gets applied is we create so in ThoughtWorks have defined this way of you create a fitness function. So by the way, you don't have to, I think, employ this formal practice or adopt this at all, but I think it's really good to understand the concept. So you create a fitness function. A fitness function is a term that's been borrowed by evolutionary biology. It describes the likelihood of like survival of fitness, survival of the fittest. It describes the likelihood of a species to survive, likelihood to survive of a species. So then the fitness function actually represents our priorities, right? We can actually apply this fitness function to our architecture and see if it matches our priorities or not. For example, in this case, in this example that I put here, high throughput, for example, is more important than low latency, for example, or data security is more important than usability. So once you define this, then and it make sure your team is clear about this, you can design your architecture accordingly. So the next thing I want to mention is, I think this is a good heuristic for designing a base architecture, because as we said, as we now accept our architecture, especially when we're moving fast, it's a living entity and it's going to grow and evolve. So I think it's a really good heuristic to start with keeping complexity low. And maybe I want your attention on the left side of this or the right side of the screen, where is like there's a chessboard, right? Like, why is that? So I put this because if you ever imagine like we're looking at a chessboard, or like I take a photograph of a chessboard in the middle of a game, you're not either one of the players. Sometimes, especially if you're not too experienced with chess, it's really hard to understand the strategies of each player, or it's really hard to understand what is the reason, what's the purpose of each element on the table, each element on the board, and what is the strategy of either player and what's going to happen next. Like, it's really hard to understand the behavior, what's going to come next, unless you're really experienced chess player or really know about this player. And that means there's a hidden complexity right there. Like, we don't know what to expect from the system, we don't know what is next, and this is exactly what we want to avoid in our system. Like, if you look at your architecture, we want architecture to express its behavior, right? To not hide it, to really explicitly, like as much as explicit as possibly express the behavior, so that you can actually grow in it. So I think that's why I feel having a base level of, so like if you want to make a decision, if you want to make a trade-off designing your architecture between complexity and performance, between amount of resources, I think it's a really good heuristic to start a base level of architecture with a lower complexity, so that it's really faster and easier to grow and let the architecture evolve. Which I can connect back to the quote that I have just told you. More than often, spending 10% extra time perhaps to build the architecture with the lower complexity, or have more resources, or have more latency, will avoid 90% of the issues that you'll face later otherwise, and it will make you grow your architecture, evolve your architecture faster. So next is, you have this big design. Now you need to split it into parts, split it into chunks, so that you can work on that will complete the puzzle and become your product, right? So how do we go about this? I think a great rule of thumb is you first do the things that has high value and high complexity. You should prioritize these type of parts. So that basically translates into parts that connect the pipes and build a walking skeleton, for example. Parts that are complex to build, risky, parts that holds unknown. So basically, again, a rule of thumb is you face the tough things first. You face the tough parts that may uncover risky things that maybe your team lacks skill, maybe it's a complex logic that you need to build, maybe it's a complex infrastructure, that you want to face those things first. And also, instead of just to go back to the first point, instead of building parts of a body separately, imagine building parts of the car separately and connecting them in the last week, at the last minute, I think you should really consider having a walking skeleton from week one, so that you get feedback, you experience running it, you know how it feels like. And I think you may uncover things you wouldn't otherwise. This is something I cannot emphasize enough, the benefits of it. So the next part is, now we're going into more practical things, is integrations. So integrations is usually in this big complex systems, this is the most critical and delicate parts, because these are the parts where most incidents and issues occur, and they need to be treated really with delicacy, and they need to be secured. So we can divide this, how to secure integrations, into two, like downstream integrations versus upstream integrations, and there are different patterns that you can apply them. So for downstream integrations, you can apply timeouts, retry, backup policy, circuit breaking. I'm not going into details of them. I'm going to talk about a few books. I'm going to mention a few books that you can learn really, really deep information and how to do things and get experience of those. But like timeouts, for example, but the main idea is simple. If a part of your system breaks, it's like a system design principle. If a part of your system breaks, the rest should be working as best as possible. And in order to do that, you need to be able to isolate the failure, right? So if a downstream service is failing, instead of waiting for that service for 30 seconds, you should time out and then use that resource instead of waiting to do some other stuff, right? Or for example, let's say circuit breaking. If a downstream service is really having a hard time under high load, etc., instead of hammering it and having errors all the time, you should just do circuit breaking and give that downstream service time to breathe, back up, and then you can try it again. And for the upstream direction, it's basically similar idea, similar principle. If a part of the system breaks, you shouldn't let that failure leak into the rest of the system. So there are practices called bulkheads, load shedding, and rate limiting. So bulkheads, for example, compartmentalize your resources so that the failure doesn't leak to the other resources. Or if you have some issue like a high load that's eating up all your resources, you compartmentalize it so that it doesn't eat up all your resources that impact other parts of your system. So load shedding and rate limiting as well. They make sure your system performs still at a maximum capacity, even under high load. Like doesn't let your system gets hammered, basically. So one thing that is really, really important, I feel that I want to mention here, is I think you should implement them in the beginning. You should implement them while you build your integrations. Don't add them. I've seen practices of like habits of adding these things while productifying the new implementation 1 week before shipping, before releasing it. I think this is an anti-pattern. You should add them as soon as you build the integration, so that you can actually test them. You can tune them. You know how they react. You know how the system reacts, because sometimes these things are really hard to predict with the complexity increases in the bigger system. So you face the error scenarios, you face the tough situations again while building as early as possible. So the next thing is testing. Of course, it's great if you have so I'm going to skip like test and pyramid, how you write tests. I think we're going to approach a little more high level in terms of testing, how you test your product. I think it's great if you have a staging and testing environment that you can ship to, and you can, while building, before you release it to your users, you can actually get feedback. You can actually see how your system behaves. There are two things we need to consider, make sure we cover here: load and diversity. Load, as we need to make sure we test our system with a load that it's gonna see once we release it, right? Because we need to face those scenarios before our users do. And the other one is diversity. Like, don't test if you're dogfooding, if you're testing your features yourself, don't test it with just one user. Try to create as much diverse scenarios as it can represent real life. So one really good practice for this that you can apply is shadow releasing, right? Shadow releasing means you release a feature. I think big tech does this all the time. You release a feature, but only a portion of your users, without making this big announcement or without marketing about it. You just release it for a portion of your users so that you can get the most scenarios you can get the most feedback, find out edge error cases, This is a really good way of testing that will give you load and, most importantly, diversity that you need to make sure your product is working well. So the next one is building for resilience. This is a really good heuristic. I want to put as much content as I can put in this slide actually, so maybe you can take a photo, screenshot even. So building for resilience, what does it mean? So I think it's a really good practice to map out possible problematic and error scenarios. For example, what those scenarios could be. For example, there could be a sudden increase in the ingress load. Your database may become bottlenecked. You should map this out and imagine how it would play out. Or for example, one of your downstream API calls are being throttled. What happens next? Or your cloud provider is having issues. Your caching cluster is unavailable. It's really crucial and super helpful to make the decision how to react to these before they actually happen. Instead of a Saturday night 2 a.m., you should actually on one person on call woke up from the sleep making this decision. As a team, you should make this decision before, and then perhaps build the tools around it so that you can actually overcome these problems as best as possible, and document this. Have a runbook. Other things I can mention about building for resilience of good patterns is auto-scaling warm-up. So most infrastructure technologies, infrastructure providers support some kind of auto-scaling. If you know how to do this, it could be really good, helpful, and if used consciously. And also warming up, like if, for example, if you know every Monday morning, or let's say every Saturday night, you have a huge load, you can actually warm up your infrastructure so that you can be resilient under high load. So the next two things I think are really important, and we should be opting in for these concepts whenever we can. First of them is immutability, a concept that's been highly popular in the last 10 years with the data storages, with more data analytics and data processing work is getting higher, getting more popular, getting more frequent. So one important thing that immutability does is it let us retry parts of our flow, right? If part of your flow is immutable, if there's an error happen, if there's high load, etc., if there's an issue happen, you can just retry them later. And it gives you a lot of power to overcome issues when they happen, which most of the time it's not a matter of when, it's not a matter of if, it's a matter of when. The next one is compartmentalizing. So compartmentalizing let us deprioritize less important non-time sensitive tasks, for example. And the other thing is you can scale them separately. Like if, for example, you're reading a message, like your system reads a message and then does some job with it. If you compartmentalize reading a message and those different jobs that you need to do, for example, notifying your users, maybe you can, on a high load time that you need to send 50 million notifications, you can just scale it separately without touching your whole app. It is really, really powerful. And the last one I can mention is runtime configuration management. This is a more or less really well adopted and quite straightforward approach, but it really helps to be able to have a configuration management that your system can read without the need to deploy new code. Like for example, you can have kill switches. You can change your infrastructure even. You can have a number of replicas, or you can change certain thresholds during runtime depending on how the environment of the system is, depending on your high load, low load, depending on if you have an issue or not. I think this is a really good tool during tough situations as well. So the next one is observability. I'm going to move myself just here. Perfect. So first thing about observability is add it while you build it. This is really, really crucial. Again, don't add it while productifying your product in the last week. Add it while you build it, because it's really easy to miss. I think it's really straightforward to add it while you build it instead of being lazy, let's say, with respect, instead of just adding it later, because later in the last week, if you're trying to add some metrics of the flow that's been implemented a few months ago, it's really far more easier to miss things, and it's really painful to realize during an incident you miss a metric that you wish it was there. You can't just go back and add it. So my first recommendation would be added value build. And I think the other thing is, other good recommendation I would have, start with the question. Like start with the question and how do we know if our product is working well? Like what could be the data that shows us, prove us our product is working well? This could be, for example, a success rate of an API call is above this level, a response time, P95 response time for any given user request is below this level, a number of requests per second is around this. It could be things like this. You start with a question, but also know that you may not know all the questions that you need. So emit data generously, really generously. There are efficient libraries. I think this could be a good heuristic, and start alerting from day one. Like start getting those alerts so that you can tune them, test them, and know how to react them. And so this is a mode of systems. I'm going to talk about modes of systems where like systems behave differently under different environments. So I think it's really great we put our system, and sometimes those are really hard to predict because of the complexity that these systems contain. So it's really good to put our system under harsh conditions before those conditions happen when we're not expecting, right? So performance testing is great for this. Put your system under like a high load, high stress, so that you see how it behaves. And if the performance is something critical for you, start testing early. Put it as a gateway, so that you can make sure after every change to your logic, to your infrastructure, you're not regressing, right? And another super powerful thing is that I cannot recommend enough is run game days. Like put your system under harsh conditions. If your cloud, like, conditions as your cloud provider is unreachable, your cache cluster is gone. So like simulate these things so that you face it before they actually happen in real world. So let's recap. What have I said? I said set your priorities clearly, broadcast them, make them known. Your architecture will evolve. Let's adopt evolutionary architecture, and a good heuristic is optimizing initially for less complexity. Have a walk and skeleton from week one. Face tasks, tough tasks first. We need the secure integrations. They're important parts of our system. We should map out our incident scenarios, create a run book with the detailed explanation of what to do during tough times, during problems. Build optimizing for resilience, immutability, and compartmentalizing as our friends. Observability, we should have observability from day one, and alerting as well included into this. And performance testing probably is a really good idea, even if performance is not a high critical priority of yours. Thank you so much. I tried to really go a bit fast. I may have skipped this, but feel free to reach out to me in my email or via LinkedIn. I hope you enjoyed it. I hope you have got some stuff from out of this that you can apply it to your day-to-day job. Really happy for the chance and hope to hear from you. Bye.